How's it going, Nicholas? How's it going, Harry R09? This is a random time of day. I don't usually stream this early, but I got some new parts in the post for my my Vibe Reaper 10K, and so I wanted to give that a go. Matt's at work. Sorry, buddy. I've got some things to do this evening, so I can't do a late live stream this evening. Morning, Chevy's Not Hondas. How's it going, my friend? Just eating my pizza real quick because I'm hungry. We hungry. This is a very early stream for me. Yeah, very early stream. Yeah. This evening I'm probably gonna be at a friend's house. So I wanted to try and get this Vibe Reaper looked at this morning or this afternoon. It's currently about 10 past 2 in the UK in the afternoon, which is early for me. I mean, I just woke up. I'm not gonna lie, I just woke up. Audio Dog Florin, far away, ask me a question while I'm eating my pizza. So we got some headers. Where are we? There we are. We got some headers for my Vibe Reaper amplifier, so we can fit one of the new driver boards in without there being any risk of not connecting properly. Audio Dog Florin, fire away with your question, buddy. Whilst I'm eating my pizza, and I shall reply. Hammernock says, looks like I have a short between positive and negative. Where should I go from there? If you have a short between positive and negative of your amplifier power terminals, then you have a dead power supply MOSFET. So you need to take out all the power supply MOSFETs and go from there. Check the drive waves. Check the drivers aren't damaged. Audio Dog Florin, I have not personally used the 65N25. I've only used the 69N25. The 69N25 is far better suited, I think, to these amplifiers. My car amplifier keeps shocking me. I know what's up with that. So Martinez, is that Martinez? Martinez Regis. Sorry, buddy. I'm terrible with different with variations in spelling. If your amplifier is giving you an electric shock when you touch the amplifier case, then there's two things that are wrong with that. The first thing is that your amplifier case ground wire is missing or not connected properly. So the amplifier will always have a small wire or a screw on the board which connects the amplifier case ground to the case. It connects amplifier's ground to case. And what that does, that prevents you getting electric shock. If something goes wrong with the amplifier and it sends its high voltage to the case, then that just gets grounded and the amplifier goes into protection rather than you getting a shock. So the fact that you're getting a shock means that that's not there. The second issue you have is the fact that you are actually getting a shock means that there's probably a small hole or in one of the thermal insulation pads on the back of the MOSFETs. So the MOSFETs, these have the high voltage rail on the back of the FETs, right? If the thermal pad is broken or has a hole, then this MOSFET will be touching the case, and so the high voltage will be going to the case. And if the case isn't grounded, then when you touch it, you'll get a shock. I don't agree with that. I don't think my voice makes me sound intelligent. "6:13 AM in California." Madness. That's an early start. I would never be up that early. In fact, I went to bed an hour before that. Pro Latvian, why do you keep tagging me, my friend? What are you trying to show me? Almost finished breakfast, and then we'll get onto this driver board. Tile Food starts work at 4 AM. Holy crap, man! Holy crap! That is not a good start. That would kill me. I finished work at 4 AM. Tile Foods, you get off at noon. That's quite good. You get the whole rest of the day to yourself. Prolatvian says, "I like you. You're a nice guy." Thanks, pal. Thank you for that. I'm sure you're a lovely guy too. And cheers for tuning into the stream and keeping me entertained. Yeah, see, this is my breakfast because I went to bed at 5 AM last night after a headache of a repair. Who was with me last night during the JBL repair? I have some updates on that one. Last piece of pizza. Last piece of pizza. Bye bye. In the mouth you go. Hammer knock. That is correct. If you remove all the MOSFETs, just remove all of them. Just remove all the power supply MOSFETs. Don't try and leave any in the board. All your power supply MOSFETs, just remove them all. And see if your short circuit goes away. Okay, let's get started on this thing then. Let's remove this driver board again. So this is the Vibe Reaper 10,000 watts RMS, and this is the output board. So this is half of the amplifier. This is the output section. The other half is down on the floor, and it slots onto the other side of the board. And this thing was very blown. So we're almost there with it. I just think it needs a new driver board, which I happen to have. I happen to have a brand spanking fresh, squeaky clean new driver board. New driver board is going on the headers today. Yes, it is, my friend. Yes, it is. Got new headers in the post this morning. So that's what we'll be doing today. And hopefully we'll be figuring out why this driver board that I replaced the driver ICs on doesn't work. If we put the new driver board in and it still doesn't work, then I'm going to blame the BD130s that I fitted. You want to recoat the voice coils on the woofers. What, to increase their thermal capacity so that the glues are stronger, do you mean? Is that what you mean? Best place for price on a solar sucker. Amazon or eBay, they're like really cheap. Like really cheap. They have some rubbing on them from when the foams were being rotted. If the coils have some rubbing on them, don't worry about that. Don't worry about that. It's not going to cause an issue. You can just leave it. I had the same thing with a few DD woofers. You can just leave it and it's fine. Don't let it get to you, bro. Good morning, base of 30. Good to see you on board. Is it snowing down in Dartford? Says Harry R09. Very lightly. There's like a small flurries in the air. Small flurries in the air. And yeah, the news was like, Amber Alert, warning, snow is coming, fucking hell, guys. But yeah, it's literally just, fuck, it's nothing. It's nothing. In the UK, we are absolutely terrible at dealing with the slightest bit of extreme weather, like snow. So all over the world, you have, you know, you have some pretty heavy snow at times, and you just get on with it. You deal with it. You have snow plow trucks. You have all sorts of measurements in place so that the day can still run, so you can still get to work, and so that, you know, the world still goes around. In the UK, we get ½ centimetre of snow, and everyone's like, fucking hell, guys, I can't go to work, I can't move out my drive, I can't go to school, everyone's taking a day off, you go to bed, have a fucking cup of tea. It's ridiculous. It's ridiculous. I'm embarrassed for my country when it comes to snow. Is anybody watching here in the live stream where it's actually pretty warm right now, pretty hot, in a hot part of the world? Because I'm jealous of you. We've just had cold weather for far too long, it seems now. got you into audio stuff? I think I was like 13 years old, and my mother gave me her old Rotel micro system boombox thing from back in that era, and it had some really nice high excursion drivers and a big bass dial that you could turn up and make the speakers move, and I was absolutely transfixed by it. I would play all sorts of music on it and turn the bass dial up and watch those woofers move, and I fucking fell in love. What's the cheapest digital designs woofer not made by China parts? 1500 series. So the 1510. In the UK, I still think you're looking at about £200 for that. So it's not cheap. But that's the cheapest USA made woofer that they do. It'll be the 1500 series 10. This is why I didn't want to have to keep removing this driver board. The more you remove the driver board, the harder it is to come out again. This pin just does not want to come away from the edge here. It's just 23 degrees. 23 degrees is lovely. I would love that right now. Yeah, I mean, the fact that this driver board pads were damaged originally, and the fact I'm having to remove it twice, this is just not ideal. But it's okay because we've got headers, so we can fix it. It's not a problem. It ain't a thing. Ain't a problem. Oh, 23 Fahrenheit. 23 Fahrenheit. Holy fucking crap! That's not good. That's not good. Definitely don't want that. Yeah, I'm a Celsius guy over here. I'm a Celsius guy. I'm not one of the people that I don't like the cold, you know. I think I'd probably rather be a bit too hot than a bit too cold. Because when you're a bit too hot, you can do nice things to cool you down. Have an ice cream. Take a plunge in the pool. Turn on a breezy ass fan. When you're too cold, I find that my brain just freezes up and my body just freezes up and I don't want to do anything. I just want to sit there with the hairdryer under the duvet and fuck life. Just sit there and just be like, nope, nothing's happening today, guys. Nothing's happening today. It's too fucking cold. I am up early today. I am up early today. Early for me anyway. So it's almost the start of March. It's almost the start of March, and I'm already seeing all the Easter crap in all the stores. Because that's what they do, don't they? They finish one holiday, and then They move on to the next, and then there's no break in between. Christmas over, right guys, Valentine's Day, get the Valentine's Day stuff out, and then Valentine's Day, right, Easter, get the Easter stuff out, or Mother's Day, or... Ain't nobody catching a break in retail. That's for sure. Who here in the live chat has worked in retail before? I imagine most people probably have at some point in their life. We've just got a flurry here. Down in Dartford there's fuck all snow. There's pretty much no snow in Dartford. Probably is higher north in the country, but not here. Barely ever get any snow in Dartford, really. Why don't you use a desoldering machine? I have a desoldering machine, but it's dreadful. It really takes a long time. And to be fair, these pads are so damaged from the previous owner who was trying to repair it himself. They're so damaged that really I don't think a desoldering machine would really do me any favours on top of my desoldering gun here. Have you ever gotten into Nitro RC? Nah, I've never gotten into Nitro RC. It looks pretty cool, but... You have a bug on your logo. Do I? So this driver board has been soldered from the top and bottom of the board, which we did on the last live stream because the pads are so damaged. So I'm having to desolder it from the bottom first, and then move up to the top of the board and desolder it like that. And I think we're almost done. It's snowing in Norwich, but not 3 miles out of where I am. I do have a bit of pizza for breakfast, you know. It starts the day off nicely. You've got to start the day off with something you love. You've got to start the day off with something you love. And seeing as this board is not something that I love, I needed to get something in my mouth that I love. Okay, I think we can pretty much go ahead and start pulling this out now. Okay, there's one trace there that I need to desolder. Just a coffee and watching repair. Oh, coffee sounds like a good idea, you know. Okay, so now I've desoldered as much as I can from this. I'm just going to start very gently pulling it up off the board because chances are that there's still some very small traces attached where this is so damaged from all the previous repair attempts that this amplifier has had over the years. I just need to be very careful when I'm pulling up these pins that I don't pull up any vias or things like that. When we put our headers in a moment, it should sort out a lot of our issues. There we go. Not bad, not bad at all. Considering the condition that this thing's in, not bad at all. Got one veer there. A snowstorm in Birmingham. Crazy. I do like a bit of snow. You know, I do like a bit of snow. Okay, so I don't know if you guys can see the absolute horrific, nasty state of these driver board pads here. Absolutely terrible. And this is because the previous owner ripped the fucking driver board out without desoldering it properly. Well, the owner did this, I should say. The owner did this. Power acoustic any good? The ones that I've seen have been terrible, but I've only repaired the really cheap low end budget stuff. I've got a feeling that Power Acoustic used to make some pretty nice stuff back in the day. I'm sure somebody else in the chat will be able to supply you with model numbers of amplifiers that were good, quite good by them. I didn't ever see them in the UK much, so I wouldn't be able to tell you model numbers off the top of my head, but all the new stuff that I've seen and that I've repaired by them, like, claims to do 2,000 watts and puts out about 500. Right, so clean those pads up. So we're going to get our headers here. So these are PCB headers, 2.54mm from memory, and these are just right for our driver board. So yeah, that will slot in there. So obviously these are the wrong size, so we need to go ahead and cut some of these into size. So let's work out how many we need. So I'm going to put my my header in there like that. Take my Stanley knife and score a line where I need to cut it. So I need to cut it just there. That one there needs to be cut. Okie dokie, good stuff. So let's. I'm just going to flip my Stanley blade over because I think it's sharper on the other side of this one. I think I need to swap that over. Has anybody else in the world got snow at the moment? Wherever you are in the world, does anybody else have snow? And do you like it, or are you bored of it by now? This blade is toast. This blade is toast. Don't think I have another one just at hand at the moment though. So I live in Sweden. We have 50-70 centimeters. Wow, that's crazy, man. That's wicked. That's crazy. Are you bored of it by now? Freaking perfect out there right now. Says Chevys, not Hondas. Awesome. That's a bit better. Okay. So our score line is just there. So let's get rid of that one. Chop that off. That's going to be our first line of headers that we fit. There we go. So that's our first line. So what we're going to do is I'm going to slot this in here. Like so. I'm going to solder it from the bottom, okay? I'm going to solder it from the bottom of the board first. Then what I'm going to do is I'm actually going to pull the plastic off, okay? Actually no, I'm not going to do that. What I'm going to do is I'm going to pull these because you see these headers, they have metal pins in them, okay? And you can pull the metal pins out one at a time. And I think I'm actually just going to solder the metal pins in one at a time. And the reason for that is because we need to solder from the top and bottom of the board here on the headers, so that the thing makes a good connection, because we have lots of damaged traces. Are most of your amplifier repairs because people are running below recommended ohm load? No, not at all. Running below recommended ohm load on its own does not kill a lot of amplifiers at all. That's not the main reason that amplifiers die. The main reason that amplifiers die, believe it or not, is vibration damage. Vibration kills more amps than anything else I ever see. So if you want your amps to last, keep them off the box. Do you have a store in the UK that accepts Bitcoin for woofers? No, I don't, my friend, sorry. Wondering how you earn money from this. Seems you are using many hours on each. Yeah, that, to be fair, that's just how it's gone the last couple of days. Actually, it's not usually this long. It's just luck, just my bad luck. The last few repairs have been horrific. But I would usually have given up on them way before, but because I want to make nice content, the ones which are a headache generally make pretty good videos. So I've been sticking out, and I've been trying to go the full way on these ones that you know are really no point. But this one here, this one is a 10,000 watt RMS amplifier, and this is quite an in-depth repair. And although it's taken me many hours, I will make a fair decent bit of money on this one. So this one's worth spending the time on. This one's definitely worth spending the time on. I should make a reasonable amount of money on this one. But the JBL from last night, nah, that's a poor business decision to repair that one. But it made for good content. Okay, so that's our first header in. Your soldering iron, what's the other side? Oh, I flipped my camera. So it's now mirrored because it makes it easier for me to see what I'm doing on the screen at the same time. I mirrored it. I can unmirror it. If it's disorientating for you guys, I can unmirror the camera, I don't mind. What's the second probe on the iron for? That is a fume extractor. So that sucks all the solder flux and the soldering fumes away from the tip so that they don't reach my lungs, because that's not good. It seems like they get in the way. It does get in the way sometimes. I sometimes have to pull it up out the way. So you see here, I pull it up out the way, or I push it down to suck solder. It's actually very handy. You know, I'd much rather put up with the inconvenience of it being there, but have nice healthy lungs after a few years, than it not be there and not be able to walk up the stairs without getting out of breath. You know. What could cause loss of power? Try to drive kicker subwoofer from 150 volt RMS home amplifier. Kick's pretty good, then connected to 400 volt RMS 1 kilowatt amplifier. The one that shocks me. I'm confused at the question. Where's your power being lost? So I want to show you what I mean now with these headers. So if I now take some pliers, I should, provided these headers are decent enough and they're the same as my ones, I should be able to pull the plastic off and just reveal all the pins. Any pins that come with the plastic means that it wasn't soldered down correctly, which means I need to solder them from the top. So let's see if this works. And there we go. So you see there, the plastic there has come off and all the pins are exposed. So we've got a couple of pins here that weren't soldered. And that's not good. That means that it wouldn't have made a connection. So we need to take the pins out manually and solder them in from the top. Like so. Okay, that one's looking good. So let's pull the other pin out that didn't get soldered properly. Because this is very important. If the pins aren't soldered properly to the board, then the thing is not going to work. So it's very important that all the pins are soldered nice and strong to the traces where they need to go. Otherwise the thing's not going to work and it's going to blow again. So these headers are now going to be absolutely permanent. These headers are going to be permanent now. This is the only way to do it. The only reliable way to do it. Tile Fruit says, I think I'm going to watch this for a bit because I don't want to wire up a machine right now. What have you got to wire up, buddy? Lunch break! I just had my breakfast slash lunch, so I'm all good. Okay, that's some nice looking pins there. So So that's that one done. Let's do the same to the other one just over here. Let's get our pliers here and pull up the plastic to reveal the metal pins here. There we go. Bend those last ones back in place that just got a little bit bent there when it moved up. That's what happens when you pull on things. Things get bent. I don't think we lost any. I think all of these seem to be soldered quite nicely. Number one isn't soldered nicely. So any that are excessively wobbly, we need to solder from the top of the board as well. So this one's a bit wobbly. Now you won't usually have to do a repair to this level, because I'm hoping that most of the repairs you get haven't been screwed up by the owner or previous tech. Because that's the worst ones. The worst ones are the ones that have been screwed with before. Honestly. Uh-oh. God damn it. What we've got going on in the live chat. I got the week off, yay for me. Awesome, JKOS. I hate working on stuff after people. Me too, my friend, me too. You don't know what they did, you don't know where they screwed up. I feel like I'm playing Operation. You know that game as a kid, Operation, where you have to remove the parts from the patient without touching the sides and making the buzzer go off. I feel like playing that game as a kid has prepared me well for this sort of repair. Okay, that one's good. That one's looking nice. Let's put this row isn't so bad. This row isn't as bad as the other one. Let's put a last few bits of solder on any pins that look like they need some. Then we can just move on to the last set, which is the set in the middle. Okay, and the set in the middle is much smaller, so it's only going to, we need 3 at the end. Car amplifier can't push out 400 RMS, it's rated to close to my home amplifier. So what car amplifier is it? Maybe it's a really cheap one and it's massively overrated. Or perhaps you know, what have you got your car amplifier connected to? Because the car amp can only put out the power that it's got available to it by the power supply. So what have you got the car amp connected to? That is very important as well. Amplifiers don't make power, they just convert it from your power supply. Okay, so there was 3 pins here that didn't get soldered in on this middle one. Interesting. So we have to do those manually. There's number 1. "31 watching is quite good for this time of day because it's quite early. It's quite early for the live streams. Second pin here just going in, being soldered down to the top of the board where there's the only last remaining pad for this pin. And the last one here. Take a minute, girl, come sit down. What's been happening? What's been happening? See, now this last pin doesn't actually have a connection anywhere on the board. This is the modulator. This is the modulator output pin, so we don't actually need this one because it has no connection on the board. So there's no connection on the top or on the bottom of the board for that pin. Modulator output has no connection, so that's not required. That's not required. Okay, looking good. So we can apply the black plastic bits back on there now. And push those down. Then we should be able to swap in. We should be able to drop in driver boards and hot swap them in and out of this. Just push that one down nicely. It's not going down as far as I'd like. I think that's because there's little solder blobs at the bottom here, so just need to there you go, that's better. That's our first one. Now let's get our longer one over here. Let's push that down nicely. So what would you guys do? Would you guys run this amplifier now after this repair, or would you just sell the crap out of it? Would you just sell the crap out of this? I would sell this, personally, if it was me. I don't think you charge enough for your time, considering there's very few people in the UK that will take on car auto repair. Yeah, maybe. But you can only charge so much before it becomes too expensive to be bothering with the repair. So then you'll never get any business. So You can only charge so much. And to be fair, these ones have been like more of a headache than usual, so the repairs don't usually take as long as they have on the last few live streams. It's just coincidence with how things have panned out. Okay, so let's drop this driver board in then, and let's see whether we're making a good connection on all these pins to the board. So this is the this is one of the new driver boards here that I'm going to drop in now. Depends on what I'm running. If it was a smaller system, I would sell it. Although it's always better to have more than you need. Sure. That made a satisfying connection noise. That made a satisfying connection noise. Okay. So I want to make sure that this board is connecting to all the places on the board properly. So multimeter and diode beep setting. And diode setting is our friend. While I agree with you, I think it's a power supply demand thing. There's plenty of demand and not enough supply. Huh? Oh, I see. Sorry, I thought we were talking about like charge as in like power supply charge. Yes. 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 Yes, I think we're good. I think these are all going to be making a nice connection here. It made a very nice satisfying connection sound when I dropped it in. So I think it's about time we fire her up and see what happens. Live stream cut out for a few seconds. Okay, interesting. Let's see if I have any dropped frames. I have, oh wow, I have 661 dropped frames. Damn, son. That ain't good. Yeah, no active stream on at 3 o'clock. Weird. I seem to be getting no active stream a little while actually, for a little bit. It's it seems to drop out occasionally. So this seems good. This seems all good. I'm just going to flip it over and check that we haven't shorted out any of the pins whilst we've been soldering, because that would be annoying. Yeah, we're good. Okay, this is about ready to fire up then. Need to get the power supply board back on the top, and then we can fire her up and see if it actually works. If it doesn't work, then I'm blaming the BD139 and the BD139s that we fitted on the live stream on Friday. let's clear some space on this bench and put the other big board on. By the way, I tagged Exo in one of his video comments and told him to stop by sometime when he has some free time. I thought it'd be cool to see him in the chat. Ah, cheers. Chevy's not Hondas. Thank you very much for that. That's pretty cool. Yeah, it'd be cool to see EXO on the live stream at some point. That'd be very cool. Making some space and we can reassemble this amplifier board together with its power supply section and apply some power and see what happens. See what happens. Hi, I never saw you streaming, says Nuke Gaming. How's it going, pal? That's probably because I've never streamed at this time of day before. I usually stream much later on in the evening for me. So depending on where you live, that might be an inconvenient time for you. So. Basehead 30. Bruce hasn't been online in a few days. Yeah, Bruce is a busy guy, man. Bruce is a busy guy. Probably a busier guy than me. So yeah, this is the power supply board for this amplifier. So this turns into one hell of a big amplifier. Do you think EXO should start live streaming? That would be quite cool, wouldn't it? I'm sure that would go down a treat. He'd get loads of viewers on the live stream. Bruce has tried. Has he tried? How many webcams do you have? I have... How many cameras do I have set up? I've got 1, 2, 3, 4. 1, 2, 3, 4. I think there's only 4 set up at the moment. I do plan on having more camera angles set up. So I've got my side cam here. What's up, y'all? I've got my main top board. I've got my top board plus scope. I've got my zoom in cam, scope cam, internet stuff. Zoom in Plix, what's that? What solar station do you use, Sam? I use an AOUA, which is AOYUE 2738A. It's not bad, it's very cheap. I don't know if I'd recommend it. You could probably get something a lot better, but it's they're pretty cheap and it does the job. You'll find that the soldering iron tips, they have the heating element in the tip and they die really often. So you'll find you're spending quite a bit of money on tips. So I'll probably look to upgrade to something, maybe a Hako, because I like Lewis Rossmann. Okay, so this board is now together. So we need to see. Last time when we fired this up, the amp came on. We didn't have any switching on the output section, and the amplifier went into protect after a few seconds. So let's see whether that's still the case. I'm not massively confident at this point. I've got a feeling we might still not have any switching on the output section, and it might maybe do with those 139s that I fitted. I don't know. Did you do a video on your Dell PSUs? I did a long time ago. They were slightly different models. It's pretty simple to set up though. All the information's on Google. So I'm just putting my ground on the virtual ground here. Okay. Change my scope settings so that we're correct for seeing the high side switch. Yep, there we go. That looks about right. Reject low frequency. Should have 9 volts sitting on the power supply. Yes, we do. So let's start pulsing this thing and turning it on. So we can see the main rail voltages there are starting to climb. We've got plus 22 and minus 22. So let's keep this going. Our red LED for protect is flashing as the thing pulses as we charge the main rail capacitors. I'm going to take my other probe here and I'm going to actually just attach it permanently to one of the rails so I can monitor the rail and the switch at the same time. Huh, why isn't that working? Why isn't my second probe working? Ah, that might be why. There we go. There we go. $71 volts, 74, 77, 79, 90 volts. Aha! We have a switch! We have a switch! We have a switch! We saw a switch there very, very slightly. We have a switch. Do that again. So it's coming in and out of switching, and I think that's just to do with my power supply being very, very small. So what I'm going to do now that I know it switches, and it's getting longer, each switch period is staying on for longer. Okay, so I think we need to try a 12 volt supply now, a slightly more powerful 12 volt supply, and see whether that switching stays active. I'm just going to check the heat on these output MOSFETs, make sure they're not getting stupidly hot. We've got some very small lukewarmness on these solo ones over here, because over this side we fitted one FET per bank, and the reason for that is just for ease. The other side is staying stone cold, which is nice. So imagine if we fit all the FETs to this other side, then they'll also stay stone cold. So now that we've seen some switching on this, woohoo, woohoo! Let's put a bigger power supply in and see if the thing stays on. So yeah, the issue was either the driver board still had a couple of issues on there. I'm receiving a phone call. Just bear with me for one moment. So is this a subwoofer that you put together yourself with a plate amp, or is it the plate amp that you built yourself or designed yourself? Yep. Okay. Okay. No, plate amps. I've had. I've also had hit and miss success with the plate amps. I've worked on a few of the Yamaha plate amplifiers, which are class GH. So it's class basically a class AB that then goes to class D switching at high output, and they're very, very fussy with the parts that are used. So because they're quite old now, the circuit will have been designed very, very specifically around the components at the time, and these days you can fit, you can usually find replacement components like replacement MOSFET parts and things which are much better and more modern, but the circuit was never designed with those in mind, and they have very slight different tolerances, and it's quite difficult to find ones that are modern that you can buy in today's day and age that will work with the circuit reliably. So it depends on how the circuit's been designed. I can have a look and we can bring it into the workshop and see where it's failed. It's probably, you know, these amps, if something dies, it's usually the output transistors. So we will have a look and see if that is the case, and see what the originals are. If they're still available to purchase in their original form, then that might be the best way forward. If not, I can see what modern parts will work with it. But yeah, it's either going to be one of those ones where it's a nice easy repair, and with the plate amp, it's either a nice easy repair, you replace the drivers and the output transistor parts and it works again, or it could be an absolute headache and it. So I'm just hooking up the bigger power supply to this board now, and we'll see whether the amplifier stays on. Okay. So the rail voltage is going to be a lot bigger now. Rail voltage is going to be a lot bigger now. So we had around 120 volts before. We're probably going to be seeing around 150 now, which is scary stuff. It's pretty high voltage things going on. Okay, so you can see the rail voltage climbing there much quicker this time. So we're already up at about 50 volts there. Switching! Switching! Woohoo! And the relay clicks in and it stays on. It stays on, guys. It does not turn itself off. So let's do that again. Whoa! Pooh! Woohoo! Holy moly! Did you see that? So that is a MOSFET on the output section which went poof. So the only explanation for that could be that that MOSFET was on its way out anyway. Whoo! So what I'm going to do, because this amplifier now works, you know, we have drive. So what I'm going to do is replace every single output MOSFET with a brand new batch, because that will get that thing working. And the driver board, I think, will probably have survived that, because we are only running a very small supply. Yeah, we're only running a very small supply, so the driver board probably survived that. If the driver board didn't survive that, it's no worries, because I've got a second brand new one over here as well. It's strange that that exploded so badly like that, because it wasn't heating up a moment ago. that looked. What did that look like on the live stream on the camera? I didn't actually see what that looked like here. How bad was that? Boof! Ting went boof. Yeah, I've got a lot of hours in this amp so far, but I think you know, we run these on the low current supply for a reason, and that's why we run it on a low current supply for a reason. Damn it! I can't get OBS to actually do a window capture. I can't get it to window capture correctly. Come on! I don't want to capture the chat window, for God's sake. Never mind. Never mind. I'm just going to have a quick look at what was I going to look at just now. I was going to see what it looked like on the live stream. That explosion. Maybe I'll watch it back later. Ah, there we go. I see some smoke. Here we go. Here we go. Here it is. Let's put the sound on so you guys can hear. It does not turn itself off. So let's do that again. I need to turn my workshop stuff on. I want to see that back. I want to see that back. Whoa! Poo! Whoa! Woohoo! Okay, so you can see the rail voltage climbing there much quicker this time. The bottom corner. So we're already up at about 50 volts there. It's the bottom corner that went. Whoa! Madness. So yeah, what we're going to do is we're going to take all of those out. Woohoo! And the relay clicks in and it stays on. And it stays on, guys. Fresh new it does not turn itself off. So let's do that again. Whoa! Poo! Woohoo! That's good times. That's good times. Holy moly! Explodes on live stream. Did you see that? So that is a MOSFET on the output section which went poof. So the only explanation for that could be that that MOSFET was on its way out anyway. Woo! So because I need to remove all of these FETs anyway, what I'm going to do is I'm going to take all the FETs now works, and I'm going to then check the driveways on all of the pads MOSFET with a brand new batch because that will get that thing working. I'm interested to see whether the driver board survived that. It probably did. The driver board, I think, will probably have survived that because we are only running a very small supply. Yeah, we're only running a very small supply, so the driver board probably survived that. If the driver board didn't survive that, sorry, I left my live stream playing. That's why you can hear two Sams. My bad. Sorry. All the Sams. Yeah, sorry for that. What was I saying? I was saying what I'm going to do is I'm going to remove all of these output MOSFETs because I need to check what I'm going to do. Because one of them just exploded, I don't trust any of them now at this point. So I'm going to remove all of them. And I'm going to load up with a fresh batch. I'm going to order a whole load of fresh, brand new ones. I'm going to fit those in instead. But by removing all of the outputs here, what I can do is I can actually check the drive waves on the driver board with all the FETs out, which is useful. So let's get to removing all the FETs. Let's get to removing all these goddamn FETs. Do you think that hurt the driver ICs? That's what I'm about to find out. So what I'm going to do is I'm going to remove all the output FETs here. And when I remove all the output FETs, I can measure the drive wave on the gates without the FETs in. And that will tell me the health status of the driver ICs. Please get a more user-friendly work environment arranged. Would like you to make it to old CNIT all tech. Would like you to make it to old CNIT all tech. I don't understand that last sentence, sorry buddy. Am I FET up yet? Yes. Let's make sure there's no rail voltage lurking on this board in the capacitors. Let's make sure there's no rail voltage still lurking in the caps here. Nah, we're good. No rail voltage lurking in the caps. We're almost finished. We're almost finished with this. We had it working. I just think that there was a dodgy FET from before that decided to explode in my face. But I think we're nearly finished with this one, guys. And then we can package it up and send it back to the customer with a warning label that says, "Only use if you do not value your life." I'm not actually that hunched over. It's quite a comfy position for me, this. I'm not actually that hunched over. I know it looks like it on the camera, on the side cam, but I think it's just the angle. The only thing I could do with is a nice cushion for my butt, because this is not a very cushioned chair. Should I take the other side of the FETs off? There's a shortage not there. If you're going to be replacing the FETs, you need to replace all of them. Like, until you really know what you're doing and you can start replacing just a few banks at a time. I would personally replace, if you want a fail-safe repair, if you want the repair to have the best chance of just working when you finish, just replace all the FETs. Pro tips from me, Sam, put some big resistance like 47k on the rail caps to help discharge time. Good plan. I don't think I've got any resistors that are big enough and high enough resistance at this time. So what I'm doing is any time that I want to discharge the rail caps, I'm just quickly discharging them through my dummy loads, which are, I've got 2 series together to 8 ohms. So I drop an 8 ohm resistor on the rail caps, get a small spark, and they discharge within less than a second. And that's been working for me. How's it going, Lauren? Good to see you, man. You missed an explosion if you've just joined us. We had an explosion. But I think we're alright. I think we're alright. I think the explosion is not too much to worry about. Yeah, you missed an explosion. Scroll back a little bit through the live stream and you'll see it. Like, you only just missed it, I'd say about 5 minutes ago. 5 or 10 minutes ago. What happened last night with the driver board repair? Ah, okay, so if anyone was watching me last night, with the JBL GTO driver board repair, the driver board was fucked. So we basically forced the driver board into operation with some help from H1 Nicholas on the live chat. So we forced the driver board into operation by screwing around with the TL494 chip. So that got the amplifier up and running. But we had some, so once we got the amplifier up and running, eventually, after many hours of screwing around with the driver board, I noticed that I had about 2 volts DC offset on the speaker terminals. And after the live stream was stopped, I looked over the board with my eyes one last time before going to bed, and I spotted that there was some, I was going to make fucking no money on that repair whatsoever, really. But I let the customer know that it was going to be an expensive repair, and he said, you know what, buddy, don't worry about it. He said, just leave the amp, just use it for spare parts. So that JBL GTO 4001 I was working on last now belongs to me, because the customer doesn't want to pay for the expensive repair on it. So I now own that amplifier. So what I'm gonna, which is a better thing for me, because it means that if I can get it working reliably, then I can sell it, and I'll make a little bit of my money back from my time on the board. So we'll get it working, but now that it belongs to me, it's not a priority. It's not a customer repair. It's not a priority. So I'll come back to it. I'll come back to it when I'm a bit less busy, and we'll get that thing working. We'll bring it back from the dead. JBL GTO amplifiers are actually fantastic. It's worth repairing it most of the time, unless your amplifier has as many issues as the one I repaired last night did, in which case it might not be worth it. But we didn't know that until we got stuck in. Until we got stuck into the repair, we didn't quite know how much of a headache that was going to be. Because power supplies are usually quite simple, but the driver board was just like beyond fucked. Do you talk about the pics on Facebook yet? Yeah, I put some pictures up on my Bearvis Facebook page last night after the live stream of some of the crap that I found. I'll show you guys in a minute if you like. Well, once I've taken these FETs out, I'll grab the JBL and I'll show you where the problems are in the output section, or maybe a bit later. Suck all these holes clean of the old solder so that we can fit the new FETs when they're ready. The new FETs won't be here for about a week now, but I can get this amplifier probably working on the bench before then, so you guys can see it. So I'm going to have to order a whole load of fresh FETs for this. I wonder if we can upgrade them. So this uses 24N50 FETs. So I'm going to see whether there's any upgrades that aren't too much more expensive. I don't want to pay out like double the money for better FETs because it's not worth it. But if there are some FETs which are a similar price that are better, then I might get those. A bit like we did with the Ground Zero 4K repair. That was one of my very first amplifier repair videos. We fitted 69 N25 FETs and they are much better. They're very, very good FETs. Nice little FETs. Good FETs for running a output section. They're fast, they're easy to drive, they have low capacitance, low gate capacitance, low gate charge, high current handling. They're very nice FETs. Decent FETs generally cost you anywhere between 80p each, 80p each and £5 each. Depending on what they are and where you get them from, and also loads of variables, But don't get yourself confused, Class AB amplifiers don't use FETs, they use output transistors. MOSFETs are used in switching applications like Class D and switching power supply applications. Not in Class A. Well, you actually, no, sorry, you can find MOSFETs in Class AB amplifiers. If some modern Class AB amplifiers have MOSFET final, so they use MOSFETs on the output section, but it's less common. It's less traditional. What would the amp do if I tried to run it without one side of power supply FETs? It will get hot and possibly blow if you have a powerful enough supply turning the amp on. So don't do that. Never run the amplifier with only one side of power supply FETs in, because it will not work and it will get hot and blow up. My amps used N and P channel FETs. They're quick so that I could get something 180 volts. Okay. Okay, so all FETs have been removed now. So let's just clean this pad up a little bit, because we've got a couple of pads over here which look a bit brown from where something obviously got a bit too hot at some point in the amplifier's life. And then we're going to fire her up without any FETs attached, and I shall show you how to measure the drive waves, because that's important. I got the dummy loads from eBay, from China. I think it was £90 in total, and I bought 4 times 1000 watt 4 ohm loads. So I could use one for 4 ohm, 2 for 2 ohm, or all 4 for 1 ohm. And I think it's better buying multiple smaller power. Oh look, there's the top of our front of our FET, the blue. Is that going to focus? So let's reattach this then, and let's measure some drive waves. Before we turn it on, I can quite quickly see whether the driver IC survived or whether it got obliterated. We can take our multimeter and put it onto diode setting. And what we can do is we can read the diode values between gate and ground. So if we put it on pins 1 and 3 of the side that didn't just explode, we have 482 one way round, and a climbing value the other way around. So that was 482. So let's go over to this side, and the FET that exploded was about here, wasn't it? So 482. So it's possible that the driver did survive there and didn't just die. So that's good. That's a good sign. Driver is unloaded. Good to test. Yes, my friend. Very good to test. This is probably what I should have done from the start. I should have just not trusted any of those FETs that were in there to start with, and just done this from the very beginning. I'm going to switch back to my 9 volt power supply to lower the rail voltage on the outputs to make things a little bit safer again. Multimeter mirrored. Yeah, I've mirrored the camera so I can see what I'm doing. Everyone's talking about that being mirrored, so I'm probably going to mirror it back. Sorry guys. Find it Logitech. Let me just spin it back round so it's the correct way round. That's better, isn't it? I just searched dummy. I literally just searched dummy load. Where's Chris? Where's Chris's comment question? What do I look for on eBay to buy dummy loads? I think I just typed in dummy load. I think that's literally what I searched for. It was a fair few years ago now, so I don't even know if the ones that I bought are still there, still available. But that's what I bought and that's what I searched for. Hi Jesse! Just popped in quickly during my break because I was noisy on my notification pop out. Hey Jesse, you missed an explosion. We had a massive explosion. Like, I'm talking poof. The amp went scrap pop. That was fun. Yeah, we had an output MOSFET just go bang. So the amplifier is now switching. So we have switching on this output section, which is the first time we've seen that since we started repairing it. And we had nice looking switching on the 9-volt power supply, but it didn't stay there. It fell back down and came back again. So I plugged in the slightly bigger 12-volt power supply, and it's still not massive supply. It's only sort of a mediocre size supply. And the switching came on for about 10 seconds, and then one of the FETs went boom, like a boom. And I think that's one of the FETs that went bang was actually on the side of the amplifier that I haven't touched yet. So I think it was just a FET that was probably on its way out. We just tickled it enough that it got unhappy and blew its load. See you later, Harry R09. See you later, buddy. Good to have you on the stream. When I edit this video, I'm going to edit all of these live streams of this 10K repair. I'm going to edit it down into about an hour long video, or maybe less. I'll try and cut it down quite short this time. So you'll be able to see, so far this amplifier has exploded twice. We've had one capacitor go pop on the output section, small one, and then we've had one output MOSFET go pop. Okay, so that's all back together. So no FETs on the board, so we shouldn't have any more nasty unexpected explosions, hopefully. So what we want to do now is just check that we have good drive wave, and to check that we have good drive wave, we're probably going to need to feed this amplifier with some sine waves. But I'm going to just power it up first without, just to see whether it likes coming on without any sine waves. Sometimes it needs a sine wave, sometimes it doesn't. I think I can put my probe on one of these I'm just trying to find where to put my probe so I can measure the rail voltage here. I think I'm going to put it on one of these rectifiers over here. For the third time now, do you remember the dual 9921s from last year's Mod Nats? Yeah, of course I do, buddy. I can't read everything in the live chat. It goes a bit too quick. So, if you've got something you want me to respond to, tag me so that I see the Orange Bear vids, because then I know you're talking to me. And if I don't respond, just say it again. I can't read everything in the live chat. It's too much. Too much while I'm trying to work. So, rail voltage is building again. 44, 46, 48, 51... etc. $78, $80, $83, $86, 90 volts, 100 volts. There we go. So I don't think we're going to get any... Oh, here we go. We've got some drive wave. See that there? So we have a drive wave. Nice. So I'm going to put this on AC coupling so we can actually zoom into that drive wave and see it. So that looks healthy. So we have good drive wave there on that side. Good drive wave there on that side. Yeah, that looks nice. So obviously the high side isn't going to oscillate because this is a self-oscillating amplifier. So let's check the drive wave on the side that just exploded. That also looks good. So the driver didn't die from that FET going ba-doom. So yeah, we got lucky there. Okay. So yeah, the driver board's fine. We don't need to replace the driver board again after that explosion. That was literally just a drain to source explosion. So the drain source short, it dumped the rail caps into that one FET and it went ba-doom. So the fact that that happened means that we can just go ahead now. This amplifier is pretty much fixed, is pretty much ready to go. All we need to do is we need to buy, we need to wait for the remainder of the 064N FETs to come because as you can see here, on the power supply section, I've still got only one FET per bank on the power supply. So we need to get the remainder of those and load that up. And then on the output section, I'm going to load her up with a fresh load of 24N50s or equivalent if I can find anything better. And this amplifier will then be ready to go. It's been a long time coming for this one. So that will be another live stream, putting the new FETs in and bench testing it. I won't be able to bench test it to full power because I don't have a power supply that can do 13K or more. Because that's how much power my power supply would need to provide to get 10K out of this. I was asking all these questions the other day because I want to build a wall using dual 9921s. Good shout. Just perhaps a little advice. A lot of people in the States say that the 9921s don't get that loud. There's possibly a little bit too much cone area for the motor force. I don't know. In the States, people aren't a huge fan of the 9921. The Z321, yes, but I know that's a lot more expensive. If you ask people in the States, they probably recommend that you went with like 415s instead of two 9921s or something like that. Maybe 4 9515s would probably outperform two 9921s, I think for sure. Just double check and have a think about what you want to do. The 9921s will need a very, very, very big box. Like, a lot bigger than what DD recommend in order to get real power out of them. And also another thing that I've noticed with the 9921s, people that run them hard and run them into high excursion have issues with the surrounds. The surrounds, they rip away from the cone because the surrounds aren't big enough to support the excursion, especially with the ESP Spider. So just take that into account as well. Just take all that into account and just have a look at, see what other people are saying online about those. Yeah, I'm missing photonic induction as well, man. What the hell happened to that? You know photonic induction? You guys watch that channel? That guy lives about 5 minutes from me. Yeah, he lives in, I think he lives in Greenhive. Very near to me, near to Dartford. And I've been tempted to go and pay him a visit a few times. How fucking wicked would that be if I did a collaboration video with photonic induction? Wow, the sort of fun we could have. With his power supplies, we could have some serious fun with that. Do you know why I buy those jumpers that connect the two boards? I don't. These are custom tooled for this amplifier. I would recommend just buying some copper bar from eBay and drilling the holes yourself and cutting them to size. Okay, so let's move on to something else then while I wait for all these new parts to come. I'm going to move on to a kicker. An old school kicker 4-channel Class AB, because I haven't done a huge amount of Class AB stuff yet. So we're going to move on to a kicker 4-channel Class AB. That's about enough Class D explosions for one day. Lots of vets will die if I collab with photonic induction, yeah. I love photonic induction so much. I watched all his vids 3 or more times. I didn't think he's that far away from you, and it would be interesting if you make a video with him. I'd love to. That'd be fantastic fun. Okay, Kicker amplifier, old school class AB 4-channel. Oops, just knocked the table with my knee. So, what have we got going on in here then? So we've got power supply section as standard. We've got our TL494. Then we've got our output section and our preamplifier board up here. So let's see what's the jam with this one then. So Chris, yes, the dummy loads are 1000 watt 4 ohm, and I've got 4 of them. The model of this Kicker is, I think it's 600.4. Oh no, sorry, this is the 800.4, KX 800.4. So I think quite a nice amplifier. So before we start with anything, before we start bothering with anything with this, let's see whether we have a short circuit across the power terminals. If you don't have space for 4 15s in a wall, maybe 3 15s. Okay, so plus 12 and ground. Do we have a short circuit? No, we do not. There's no short circuit between plus 12 and ground, so that's a good start. Let's go along and check there's no short circuits on the output section here. So that bank's okay. This bank looks generally okay. There's no short circuits on this bank. No short circuits here. No short circuits here, and no short circuits here either. Okay, so there's no shorts on the, there's no obvious shorts on the output, and there's no obvious shorts on the power supply. So let's try and power this up and see what it doesn't like. Time for a nap. Nah, I got a good sleep last night. After my JBL repair, I got a relatively good sleep. So Class AB, so yeah, let's see what's going on with this then. Apply some power. Get my scope hooked up. So let's just check. We have. Oh, we need to turn the scope back to the original settings that I use. So a DC coupling and reject low frequency. Yep, that's correct. Turn that on there. So let's apply some remote and see why this doesn't come on. So we're going to hold our probe on the 9 volt of the MOSFET, apply some remote, and we have nothing. We have no life, no switching there. So the power supply is not turning on when we apply the remote. Now this amplifier has a lamp, it has a bulb on the top. Let's see whether the bulb is getting any power. So the bulb, if you see here, this lamp header, when I apply the remote, that gets 7 volts. So the remote is definitely getting to the amp. The remote is definitely getting, so the remote signal is getting to the TL494. So this is our TL494 chip, which we have seen quite a few times on this channel. Zoom in a bit there. See, I only have a Saturn iron to work with, says Lauren. What's the Saturn iron like? So on the TL494 then, pin number 12 is our VCC. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this should be VCC. So, okay, our 494 isn't getting the correct VCC. So the 494 is only getting 1 volt on pin 12, 1.8 volts on pin 12, which is supposed to be the power for this chip. So it's not getting enough power to work. Which also means that we won't be getting any square waves on pins 9 and 10. Which we're not. We're not probably not getting the sawtooth wave on pin 5, etc. The 494 is not turning on. So we probably have some shorted little transistor somewhere that will be sending the power to the 494 chip. So let's take our multimeter on diode setting and let's turn our power supply off so we don't short anything out on the board while we're probing. And let's find out what this pin 12 is connected to. So 9, 10, 11, 12. So I can just about possibly see the trace on the top of the board here. I think it goes somewhere over here. Let's see. No, it goes under the chip. I can't see where it goes to. So what I'm going to do is I'm just going to start moving my my multimeter probes around the board and touching random components in the hope that I find the one that's connected to a VCC here. It's probably going to be a transistor. I'm looking for the transistor that is responsible for turning the VCC on. It might be one of these. It might be this big one here. Aha! Yes, it is. It's this big one here. So there's a big transistor here, and that has the middle pin here connected to VCC. So let's see whether that transistor is actually turning on or not, because if it's not, then that will be our issue. And is it not turning on because it's dead, or is it not being fed the right turn on signal? So it should have. Let's have a look. So with the power supply plugged in, it's got our 9 volts on the on pin 3. It's got nothing obviously on pin 2, and it's got nothing on pin 1. So it's got 9 volts on pin 1, 9 volts on pin 3, and nothing on the middle one. So if we apply our remote, you can see that it jumps up to 1 volt, just the same as the VCC does. Now this, I think this is going to be a PNP. It's a really random old transistor that I don't recognise the model of. So I think the idea with this is what's meant to happen is when I apply the remote, what's meant to happen is, you see how pin 3 is currently high? Pin 3 is currently sitting at 9 volts. When I apply the remote, pin 3 drops down to 8.9 volts, okay? And that is then reflected on the middle pin by jumping up to 1.8 volts. So I think pin number 1 is meant to then go down to about 0 volts. So if pin 1 goes down to 0 volts, and if this is a PNP, it will turn on, and it will send the 9 volts on pin 1 out through pin 2. So let's see what's feeding pin 3 of this transistor. Because by finding out what feeds pin 3 of that transistor, we can see why it's not being pulled down to ground effectively. I think you're tired or lack of oxygen in your body. Nah, I just spent too long in the workshop. Too many late nights in the workshop, my friend. So, pin number 3. Let's have a look and see where that cheeky thing is coming from. It's probably coming from another transistor around here somewhere. Pin number 3. Where are you, buddy? Where are you coming from? Looks like, oh no, that's not, that's just a capacitor charging. See, it's gone off again now. Okay. Pin number 3. What I'm gonna do instead is, rather than looking for pin number 3, it seems to be quite hard to find, I'm gonna put one probe on the remote input over here, in fact. So one probe on the remote input, and I'm gonna see where that turns up on the board over here. Okay, so it looks like it comes in over here on this resistor. Hey, that's strange. Look at this. Look at this. That's funny. You see this here? This resistor is labelled up on the board as D18, diode 18, and it actually has a marking for a diode, but it's actually been fitted with a resistor instead. How strange. How strange. I wonder if that's got anything to do with it. I wonder whether that's a repair or whether that is a modification at the factory. Okay, interesting stuff. So that's going there. Okay, so the remote voltage comes in there, and it goes over to the other side of this resistor. And where does it go after this resistor? Where does it go after this resistor? This is how you work out how an amp works without a schematic. You look at the traces, you work out where things are connected to, and you go from there. I might just take the board out of the case here so I can look at the bottom of the board, because looking at the bottom of the board I'll be able to follow the traces a hell of a lot easier than I am now. I think we'll take this thing out of the case because I want to see where this remote is exactly going to after it comes out of this resistor. Where does it go to? Without having to probe around every single damn component over here, and I'm still not finding it. Yeah, let's take it out of the case, because we're going to need to take it out of the case anyway to find out what's going on. Vape break. Maybe. ASD Board says, what did I miss? So if you are recently joining me on this live stream, you have missed a few things. You missed me almost finished repairing the Vibe Reaper 10,000 watts RMS amplifier, only for it then to explode on the bench and kill a output MOSFET. But that's not a problem. That's not as dramatic as it sounds, because it killed one of the output MOSFETs, probably because that FET was on its way out anyway, because I didn't take all the FETs off the board, because they were mostly reading okay. And the side where the FET exploded didn't seem to have been damaged, but it obviously had. So, but the FET exploding didn't damage anything else. It didn't kill the driver board that we just fitted. It didn't kill anything else, because I use a very small low current supply, and that's why. That's the reason I use a very low current supply when I'm testing these amps on the board, on the bench. So yeah, the FET exploded, but apart from making some pretty fireworks on camera, that's all it did. So what we're doing is we are ordering a fresh load of FETs, all in the power supply, all in the output section, and we're charging the customer a flipping bomb, because the parts on that amplifier are going to come to around about £150, perhaps a bit more. And obviously my time on that amplifier is also going to be quite expensive, because it's taken me many hours, because there was literally everything wrong with it. So the customer is going to be having to pay out for that amplifier, because I've pretty much rebuilt it from the ground up. I saw the explosion and you taking the FETs out. Okay, well, I've now moved on to a Kicker KX 800.4, which has a faulty power supply remote switch on circuit. The circuit which turns on the TL494 is not getting VCC on pin 12. Making moves, shit on the dance floor. Gotta groove on, dancing in riddle hardcore. From the front to the back, that's where I was at. You know the apple tried to do like that. Greg David Alario, DJ, it's all up to you. And the crowd go wild. Tell me what you gonna do. 3, 2, 1. When I can't say both, select off. Yeah, port noise you can get away with by ensuring your vent velocity is low enough, and making sure that you properly flare your ports. My Celestion 18, yes, my Celestion 18. Would that have been in Wembley Arena during Craig David's 2001 concert there? 2001, when did I get that? Yes, very possible. Yes, very possibly, actually. It was refurbished, it was taken out of there probably a few years after that. Not, it was probably mid-2000s, perhaps. So yeah, it probably was. DS18 is a resistor on other boards as well. Says Forsaken. Oh, very nice. Weird, hey? So perhaps Kicker thought that it needed a diode and then decided that actually a resistor was better in that location. Thanks for checking that out. Thank you for checking that out, Forsaken. Very useful. Preamp board. This amp's got a lot of screws. This is quite a nice build quality in terms of how it's fixed to the heatsink. It shouldn't suffer from vibration damage too much. I don't think JBL makes a GTI anymore, which is a shame. JBL have made some lovely stuff. And especially for the money, for the price that they make them for as well. Really, really well. JBL are definitely the kings of the budget performer. So this board says KX804 version 3.0. So they got to version 3 and still hadn't decided that they wanted to change this diode to a resistor over here. Any more screws in the case? Yes, there are some more screws in the case. Way over here. Checking this girl next door, when I come from now, she won't say, hey boy. Okay, that should be out the case now. That should be all the screws. Is it all the screws? Is it all the screws? Are we gonna get out the case? Are we gonna get... Yeah, the MOSFETs are stuck to the heatsink on the thermal pads, which happens on old amplifiers. They're there for so long, they just like, they don't want to let go. Never gonna give you up. Never gonna let you go. There we go. So these transistors were made in Morocco. These are old transistors made in Morocco. There we go, and we're out the board, out the heatsink. Oops. Nice, flexible, flimsy board. So let's flip her over and let's continue our search for where this thing loses or is having issues with the remote and the VCC for the 494. Lauren says, going to be off to work. See you guys later, and a good repair. Thank you very much. Cheers for tuning in and supporting the stream. Remote is here, and the remote came in. Where did that come in? Can't remember now. The other side of the board. Where was it? Oh yes, over here somewhere. There it is. So it's also there. Okay, so we have a small transistor here. Okay. So let's see where else the remote comes in. So it comes in all the way for over here. Goes la 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 da 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 da. Goes to there, and also there. Okay. Okay. So let's check this out then. So it goes to this very small transistor here. So we need to see what that transistor is doing. So we're coming in here, and we have 9 volts. Ah, look at that! It fucking works now. Look, now I've taken it out of the case, it works. Interesting. So I did scratch away something on the board here just a moment ago. Some corrosion. So I think there was a little bit of corrosion on the board that was maybe pulling the remote voltage down. Ah, finally, an easy one. Oh, I'm not sure about that though. Look at that. That's floating around all over the place. That's not happy. That's not happy. So what we're going to need to do is we're just going to give this board a bit of a clean. Because it's floating around. The switching wave there was sort of fluctuating a bit, as if it wasn't too happy about something. So what I'm going to do is take my tweezers. We're going to remove any crap that I can see on the board and just give it a clean up on the bottom. So finally, perhaps we have an easy-ish one. Yeah, there's some crap on the bottom of the board here, not very nice. Some dust and corrosion from moisture. Let's give this bit a good old clean with my toothbrush. This looks a lot nicer now. I've cleaned it. Looks a lot nicer now. See if that's made a difference then. Give that a quick old clean. Interesting, now it's not coming on again. So it was coming on a minute ago, wasn't it? So we've got 9 volts there. If we follow the path, we have 9 volts at this transistor, and we only have a very small voltage on this transistor here. 7 volts, so okay. Aha! Okay, I found the culprit. I think I found the culprit, perhaps. That just swung up a moment ago. So I think we have a poor solder connection on this resistor here, which is to do with the remote switch on. So I'm going to reflow some of the solder connections around this area, and that should hopefully solve it. If it doesn't solve it, then we have a slightly leaking transistor that we need to replace. Did you use a schematic? No, I didn't use a schematic. I just looked at the board and worked out where everything was, and used my multimeter to follow connections to work out how this amp works and where the issue is. I need some good repairs. Yeah, this one has the potential to be a good repair because there's nothing wrong with the amplifier or the power supply section. It's just the remote turn on. And so, worst case scenario, if I really can't get this working and it's not really worth a repair, I can actually just short out the remote 12 volts to the 494 VCC, and by doing that, this will force the amplifier to work. The only reason that's not done from factory is that they like to minimise the amount of current drawn through the remote. That's just for, just because, why not? But the amount of current that the 494 draws is very, very small. So we could run the 494 directly off of the 12 volt remote, maybe through a current limiting resistor. Right, let's see if that's changed anything. Little reflow. Cheeky little reflow. Cheeky little reflow. Did that do its job? Did it work? Okay, she's still not coming on. Okay, let's have a look. So we're going to follow the path of the remote again. So we have 9 volts on this little transistor, and we have a very small voltage on this little transistor. 8 millivolts on this little transistor. And barely anything on this little pad here. So I think we should have 9 volts on this pad here. There we go, 7, 9, 7. That drops off back down again, doesn't it? Where's the 494? Let's see what's going on with the 494. Okay, so the 494 is getting more VCC than it was. We're now up at 2 volts on the VCC. So we're making some progress here. The top of the board looks a little bit dusty. So I'm just going to give the top of the board a bit of a clean as well. just in case that's got anything to do with it. The amp did come on for a very short moment earlier, so I know that it has the potential to work very shortly. Just got to find out where it's not. Something's not making a good connection somewhere, or something's leaking a little bit somewhere. We need to find out that. And once we found that, we can just get this thing working. This amp's not worth a huge amount, so if it takes any longer than another 20 minutes, I'm just going to short the remote to the VCC of the 494 just to make it work. To make the customer happy. It does like the 9 volts because it turned on just a moment ago. If it didn't like the 9 volt, it wouldn't have turned on a moment ago. Either way, even if it right, so okay, this is why I know that the 9 volt isn't a problem. If the 9 volt was a problem, then the TL494 would be getting its VCC, but it would be in shutdown mode due to low voltage protection. The 494 isn't even getting its correct VCC, so it's not in shutdown, which means that the under voltage protection is not active. Okay, so we're still at 2 volts now on the VCC. Let's have a look at that main transistor that is responsible for, this is the main transistor that's responsible for VCC, so that's probably going to be at 2 volts just now. Yep. So let's just check, where's that getting it from? Again, it's getting 9 that side. And the other side it's getting 8.8. So that needs to be pulled down. So what is going to be pulling that down? That's going to be this here. That's going to be pulling that down. So that is 9. So that's going to be pulling it down. So that's there. That's 8.8. That goes to there. That is... Aha. 8.8. There's something there, so that's pulling it down nicely. I found the dodgy component, I think, guys. I found it. There's a resistor here that's not pulling it down enough. So what happens if I just jump that resistor just to see if this thing will work? Where's that one? That one is a resistor here, R48. R48. Let's measure what R48 is supposed to be. What's R48 supposed to be? I can't remember the colour codes off the top of my head, so we're going to have to Google that. Okay, we are resistor 48, which is a green, blue, orange, gold. So 4-band resistor calculator, because I cannot remember these off the top of my head. That is not some information that I want to store. Ah, David Tuitt just pledged $15. Holy Jesus crap! That's insane. That's a big pledge. Wow! Thank you very much to David Tuitt. Wow, awesome. Thank you so much, dude. That is fantastic. I'll thank you personally on because I have you on Facebook, and I'm doing some repairs for you at the moment. So I'll thank you personally. Green, blue, orange. Green, blue, orange. Tolerance is gold. So that's meant to be 56 kilo ohms. So let's put our multimeter onto 200k. And let's see. I bet it's going to be right. So it's currently sitting at, yeah, it's gonna climb to 56, isn't it? So why isn't the voltage being pulled down correctly from there? So the way that this thing works, okay, is, if I get this here, the way that this thing works is to isolate the so the 494 needs its VCC. It needs 12 volts to turn on. But rather than getting that just from the remote, and rather than putting the head unit under unnecessary stress, there's a series of small transistors here that will take the remote voltage, and they'll then separate it and isolate it from the 494. So that the 494 takes a switched voltage through a transistor rather than from the remote. I wonder whether one of these Zeners is shorted, because we've got all sorts of weird voltages going on with the Zeners over here. I think we'll give it 10 more minutes, and if we don't find it in 10 more minutes, I'm gonna just short the VCC to remote input to force the thing to come on. I wonder if it's got something to do with these capacitors, actually. No, these are rail capacitors. I don't think it's to do with that. Now that we've got a little bit further with it, let's just out of pure interest, let's try 12 volts and see if that makes any difference to how this is acting. Let's try 12 volts just real quick. Real quick. Try 12 volts. I did see this amp turn on with 9 volts though, so I know that the voltage isn't going to be an issue here really, but. So 12 volts on the screen, apply our remote, and we still have nothing. So yeah, it's not a voltage input issue. Let's see what the 12 volt changes though. Let's see if that makes us get any closer to the correct VCC on the TL494. So we now have, no, we still have 2.3 volts. That's the same as what we had with the 9 volt supply. Same as what we had with the 9 volt supply. So what did I do earlier to force the thing to come on? Because it came on earlier, didn't it? It came on earlier. What FETs are in the output? There's no FETs on this amp other than in the power supply section. This has got some really old power supply FETs that I can't remember the name of, but I shall check them in a moment. I'm just going to take a very small bit of jumper wire, and I'm going to jump the 12 volt remote to the TL494 VCC. TO220 is correct on the power supply side for the FETs. TO220 package is right. Or perhaps rather than jumping the VCC to the remote, what I might do is I might force this transistor here to be pulled down to ground, and by doing that the amp should come on, because then that still isolates the remote. Shitty joint when you flex board. Let's try it. Let's try flexing the board. Good idea. No, it doesn't seem to have any effect on it. Broken zen of the glass ones. When the board flexed, it made contact again. Yeah, I don't think so. It doesn't seem to want to be working, even when I flex it. Because it worked when I took it out the case, didn't it? It worked. When I took it out the case, it worked. So let's clamp one of our oscilloscope probes to the power supply FETs, and let's start toying around on the power supply section. Start toying around a little bit. So we need one of these transistors to be pulled down to ground when this thing turns on. So we go all the way up, so that goes up. That also goes up for a brief second and then comes back down again. That goes up and back down again. And then it goes to another transistor over here. Have you ever done a single 1510 series diesel Zions 10-inch sub? What amp would you recommend? Plenty of headroom. I'd get the dual 2 ohm and I'd run a 1000 watt RMS amplifier on that, and that'll give you enough headroom. I'm just trying to short various things here. So I really think this pin should be being pulled down to ground. So I'm going to try and ground that pin just quickly. It doesn't go into protect. It's not even the TL494 isn't even activating. I'm going to try removing that that transistor that's responsible for turning the VCC on. I'm going to try replacing that. Thermal cam, nothing is going to be getting hot here. Nothing is going to be getting hot. There's going to be just a leaking component or a dead resistor or something. Ah, interesting. So look, when I measure this this transistor that I just removed in the transistor tester, it says no unknown or damaged part. So that seems to potentially have been the issue. Now we only need a low value transistor here, because this is literally just doing the job of turning the VCC on. So we want a nice high current if we can. I just need to double check whether this is a PNP or an NPN, but I think it's going to be a PNP. 2SB 64, what is that? 2SB 649, I think that is. 649. So this is a Hitachi semiconductor. Hitachi. It's a PNP. And it has the following specifications. Minus 180, minus 160, so it's the same as, pretty much the same as the JBL thingy we were looking at earlier. On the JBL driver board, it's pretty much the same job, it's minus etc. So I can probably take one of the transistors that I was going to be using with the JBL and swap it out. It does the same job as that transistor on the JBL driver board from our repair the other night. So where did I put the transistor from the JBL? It should be somewhere over here on my bench. Let's have a look. And then who'd be interested to see what this old kicker bench is? Who'd be interested to see that? Here we go, A1220A. That should do the trick. I bet my B772 would also do the trick. Does anybody else here know with replacing these transistors, because my B772 has a higher current handling and I think it's a lower voltage, but we don't need a high voltage. This is only for switching the VCC on. So I think I could probably get away with using a B772, and that will have a better reliability factor over this high voltage, lower current transistor. I could just use one of my B772s. Yeah, let's put one of the B772s in just for shits and giggles. Somebody get that damn song out of my head. Can't stop whistling that Rickroll song. Alright, see what happens now then. Hey! So this power supply, the 12 volt power supply, has not got enough current to turn the amplifier on fully. So let's put our 9 volt supply in just to make sure that the thing works, because obviously that now turns on correctly when we apply the remote, which it wasn't doing before. So that was our issue. We found the problem, and this is going to be a nice little fix. Nice little. I spent a little bit longer on it than I needed to. I should have just replaced that from the start when I saw it was a bit bad. But I wanted to try and see if there was any other issues anywhere else. But yeah, it was the transistor that is responsible for sending the VCC to the 494. That was the issue there. The outputs are TIP35C and TIP36C. The power supply MOSFETs are good old school IRF Z46N. Let's put our 9 volt supply back in, and let's get this thing turned on. Make sure nothing in the output section heats up. It shouldn't do, because the amplifier itself seems to be fine. It was just the small transistor here on the VCC generation circuit that was dead. So 9 volts, apply the remote, there she goes, and away she goes. What voltage have we got on the outputs here? 31 volts, plus and minus on the outputs, not bad. Cool, very nice, great success, great success. We've made a relatively easy repair for once. So let's put this back in the case and let's see what power it does. Because I'm sure you'd all be interested to see how much power this old girl puts out. Good old kicker, KX 800.4. I think we're going to see at least rated power here, you know. Great success. Very nice. I like the easy repair. TIP 3536 has a huge derating. Carlos, buddy, cheers. Thanks for joining in, man. What do you mean by the derating? Do you mean that they deteriorate over time very quickly, or? That was a quick fix, yes, that was a relatively nice, simple, small issue, quick fix. Wasn't too bad on the old brain cells, that one. One, two, 3, 4, 5. Once I caught a fish alive. 6, 7, 8. Yep, that's all the screws in the main case there. I bet you like Kicker a bit more now. I respect Kicker's old school line of products. Especially their amplifiers. Kicker amplifiers have never been that bad. They've always been very respectable, I find. But just the woofers. TIP 3536 are quite good at that time. This is way before my time, this amplifier, really, so. Carlos, if you're still tuned in, buddy, what did you mean by they have a huge derating? What did you mean by that? I'm interested to find out. So we gon' start it off like this. Feel the bass all red. Turn it up, but keep the gain up. Steady, we don't wanna keep popping and blowing the pounds. The only thing you wanna hear is low, deep sounds. Got a system hooked up. Yeah, you know how we do. You know the only thing that matters how it sounds to you. So when you got your own style and you got your own flow and a passion for bass, you're in control. So the reason I don't use an electric screwdriver when I'm screwing into the heatsink here is because it's very, very important to be able to feel what thread you're screwing into, because you need to be screwing into the original thread with these aluminium heat sinks, because if you cross thread it even the slightest bit, when you go to tighten the screw up, you'll just ruin the thread inside and then the screw will just spin in the hole. And it's very important that these transistors and FETs are clamped down very tightly to the heatsink, because if they're not, what have I done wrong here? Where's because if they're not clamped down tightly to the heatsink, then they won't be making good thermal contacts to the heatsink, and they may overheat. So the reason I don't use an electric screwdriver for doing these back up is because I need to be able to feel the thread as it goes in to make sure that I am not cross-threading it. With an electric screwdriver, it's incredibly easy to just go brrr and just fuck it up. Ah, crap. And then you're screwed. Then you got to find a bigger screw, you got to tap a new hole, and it's like, ah, Jesus. For unscrewing the amplifier, yes, you can. I would use an electric screwdriver to take the screws out of the amplifier. But for doing it back up, I prefer to feel the threads with my hand. Sam, what's a pint cost at a pub local to you? Says Tom. Good question, buddy. That's very kind of you. Let's see. Local pubs generally are Wetherspoons around here. So I think it's about £3.50, perhaps. Yeah, I think that sounds about right. So to recap then, if your amplifier, if you have an amplifier that you plug in and it shows absolutely no signs of life, possibly not even a remote, possibly not even a protection light or a green light or anything at all, then what you need to do is take the amp apart and you need to trace where the remote signal goes into the amplifier. Most amplifiers will use a kind of buffering circuit between the remote and the TL494. The TL494 is the chip that controls the power supply pulse width modulation. So that's the chip that will essentially tell the amp to power up. Now, if that chip isn't getting the correct voltage to actually run at, which is the VCC voltage, which is around 12 volts, then the amplifier won't come on. It will show no signs of life. So when you apply the remote, you need to check out the spec sheet, the PDF for the TL494 chip, and you'll see that pin 12 is the VCC. That's the power input pin. So measure the voltage on that pin. If you don't get 12 volts or around that when you apply the remote, then you need to look at where the 12 volts should be coming from through the board. So like I said, most of the time there is a series of small transistors here that buffer the 12 volt from the remote, so that if the amplifier turns on, it doesn't draw too much current from the head unit, which is how it's meant to work. So there'll usually be a larger transistor somewhere on the board that is dealing with sending the 12 volts switched to VCC from the remote and buffering it and sending it to all the different parts of the amplifier that need 12 volts, like the LEDs here, the TL494, and any other chips on the board, like the fan maybe. So if that's not getting 12 volts, then I would work backwards and first of all change the transistor that's responsible for switching the 12 volts on. If that doesn't solve the issue, go backwards and check the smaller transistors that are pulling that wave down, the voltage down, so that the PNP turns on, and so forth. Keep going and changing the transistors until it starts coming on, and then you should have a successful repair. Yeah, I'm going to power this bad boy up. I just need to finish reassembling it, and then we'll power up and do a bench test, see what she makes. Deassembling and reassembling the amplifier takes far longer than necessary. It's quite a pain in the butt. Deassembling and reassembling is quite a long part of amplifier repair, and it's pretty annoying because you're not really doing anything. You've either repaired it already, or you know, it's just a pain in the arse. A pint of beer is $8 to $10? Are you serious? Jesus, that's insane. I thought it was expensive around here. Like, if you go to a cheap little country village pub, you can maybe pay £1.50 for a pint. Some universities do crazy deals where they offer like a pint for like 30p during Freshers Week. 30p is like 50 cents for a pint. Are you going to balance it? I haven't done any repairs to the output section, so it should be balanced as from factory, and there are no there's no biasing potentiometers on this amplifier, so I'm not going to make the repair cost anything more than it needs to cost. There shouldn't be any issues with the balancing of this. Uh-oh. Did I need to put this in before I screwed the... Damn it. Damn, work getting in the way of me watching the stream. What was wrong with this one? So ASD board, this amplifier had a problem with the small transistor on the power supply switch on section. and that transistor was responsible for generating the 12 volts which is required to turn on the TL494. And that transistor was completely dead. It was nothing. It wasn't even showing a reading on the transistor tester. So we replaced that, and the thing came on, and it works. I did press the sound button just now because I had a visitor into the workshop, so I muted my microphone briefly. So what do we reckon then? Rated power, yes? From this? Rated power? Should be putting out at least or on rated power. Cool. So I'm going to be bench testing this on my 12 volt power supplies and using square law correction factor to work out the equivalent power at 14.4 volts worth of input. And when I get some spare time, once the repairs have calmed down a little bit, I'll hook up the 14 volt power supplies, and I'll get them all hooked up with my super caps and stuff, so we can start actually benching things on a real life load of 14 volts. But I haven't got the time just now to spend a couple of days sorting that out. I will shortly though. I will shortly. Afternoon SDB Designs, how's it going my friend? Missed a fair bit on the stream. Explosions and all sorts. So SDB Designs, on this live stream so far, we looked at the Vibe Reaper 10K. We fitted the new driver board in the headers, which was good. We had switching, so the amplifier is coming on and the output section is working. The output switched for about 5 seconds on 12 volts of supply, and one of the MOSFETs on the side that I didn't think was blown went BANG! BAKOOM! Skrrr! Boom! Boom! And it narrowly missed my face, and it looked very good on camera with some blue spark and smoke. So I removed all of the transistors because we're going to replace all the output MOSFETs now. Now that one blew, I don't trust any of them. So I'm going to order a fresh batch of 24N50s for the Vibe Reaper 10K, and I'm also waiting on my power supply MOSFETs for the 064Ns to arrive, and then that will get loaded up, and the amplifier will work perfectly fine. Amplifier will be good as new, about as good as it can be with the state of that driver board pads. ASD board says, would you know which value the R104 resistor? On which amplifier? On this amplifier? It's a really small through-hole resistor with 3 bands. It was black, orange, brown, I believe. It was blown but couldn't measure it. AB amp. What, this one? Do you mean this one, or do you mean an AB amp that you're currently working on? I will upload the last few streams, but I'm going to edit them down because they're all like 4 hours long. So I think that's all the screws. Yep, I think that's all the screws. So let's the top of these boards actually goes on very interestingly. it kind of clips on. There's no screws or anything, it just clicks into place. So we need to put the fan back on. Then you just have to squeeze it. You have to push the so it clips down. Try not to catch your fingers because you can catch your fingers in it and it hurts. There we go. So that just clips back into place like so. And just before we power it up on the big power supplies, it's always worth doing one more last check after you've reassembled any amplifier. Do one last check on your small power supply, just to make sure that you didn't accidentally short anything out on the heatsink when you were reassembling it. Because if you plug your big power supplies in straight away after you've reassembled it and you accidentally shorted something out on the heatsink, then you've just wasted all that time on your repair and you've got to go back and start again. So I'm going to power up one more time on the small supply, just to make sure I didn't short anything out on the heatsink. It's better to test once and make sure everything's okay than to not test at all and waste a lot of time. Okay, so we have a green light. So that comes on fine. Is the fan doing anything, or does the fan only come on past a certain point? Maybe the fan only comes on past a certain point. Let's make sure we don't have DC offset on the speaker outputs, because that would be annoying. Nope, speaker outputs look good. Cool, cool. Right, big power supply time. Now this amplifier uses really tiny inputs, so I'm probably going to have to hook up my 4-gauge wire, which isn't ideal because it has a little bit of voltage drop across it when we power it with this much power. So I don't think I can fit my big 70mm cables in here. Yeah, you're probably right, the fan comes on once it gets up to operational temperature. So we've got 3 40-amp fuses. Let's see whether my 70mm cable let's see whether I can squeeze it in there. It's not gonna be particularly well put in there. It's just connected up for a quick bench test, so I'll try and squeeze it in there. Just about. I don't think I'm too happy with that connection. I might just put my 4-gauge in instead. Yeah, fuck that. We're putting our 4-gauge in. That's hanging out like a bitch. Oh, it was actually connected alright. It was there was actually enough of it in there. Screw it. Let's put the 70mm back because there was actually a fair bit of cable in there. It didn't look like there was, but there actually was. Did you get the JBL running, bro? Produced by Zenith. The JBL, so for anyone that's just joined me and wants an update on the JBL amplifier from last night, Blah, 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 blah. JBL amplifier. Yes, we've got the power supply up and running on the JBL amplifier. We've got that fixed. But what I hadn't noticed earlier on was that the JBL amplifier actually has an output section failure as well. So we have some really exploded driver transistors in the output section. None of the output transistors are dead, but the output driver transistors are exploded. So, but the update from the customer doesn't want me to bother going ahead with the repair on it, because I told him how much it would cost, and he said don't bother with it, it's not worth it. So that amplifier now belongs to me, so I can fix that in my own time and sell it on, which is better for me because that will make me some money back from the ridiculous amount of repair time that I've put into that amplifier. Oh man, this looks janky as fuck. If you could see the power connections going in here, a lot of you would have a fucking heart attack. We're trying to squeeze 70mm cable into this little 4-channel. So I don't think I have enough RCA splitters to bench both front and rear at the same time. So what we're going to do is we're going to bench test front separately and rear separately. And I know that by doing that, we're not getting a true representation of all channels loaded, because it will be less power when they're both loaded. I'm fully aware of that, but I don't have enough RCA splitters like to hand on my desk right now, and I just want to make sure the thing works. So I'm not too fussed, to be perfectly honest with you, whether it's like amplifier 1 input, so that's this one here, amplifier 1 speaker output will be this side, okay, and let's set the gain. So amplifier bass boost, no, bass boost can fuck off, amp 2 gain, la la la, bass boost off, amp 1 gain, there we go, that's what we want, amp 1 gain, that's this knob here. So what's this rated? Is this rated at 4 ohm bridge? It probably is. Let's have a quick Google. What impedance do I need to load this at? Kicker KX 800.4. I think this is probably going to be 2 ohm per channel, 4 ohm bridge. I think it's only showing me the new one. The heatsink looks different here. Yeah, okay, I need the old one. I need the old one. Images. Here we go, this is the old one. Let's visit this website. 2 ohm per channel, yeah? It says base head 30 and row and load. Here we go. There's a nice forum here. So at 13.8 volts, it claims to do 4 ohm mono per side, per amp. Yeah, so it's 4 ohm bridge, so we're going to run it at 4 ohm bridge. So for this I only need one of my dummy loads. So I've got my 2 4 ohm dummy loads here. So I'm going to connect one dummy load to each of the outputs in bridge mode, like so. I will probably live stream most days now. Like, you know, this is my daily job, so if I'm in the workshop repairing an amplifier, I might as well live stream it to you guys, and you can drop in and drop out when you're bored and you're not busy. You can drop in and see what I'm up to. Okay. Cool, let's get this bad boy fired up then. So I'm just gonna activate my foot pedal remote switch for this. I like having the remote on a foot pedal. It makes life nice and easy. If there's ever an issue, I can quickly remove the remote from the amplifier by releasing my foot from the pedal. It's a good system. Okay, let's power this baby up. Green light is on. So let's put some power into this and see where the clipping point is. There we go, there's our clip point. Let's go up a tiny bit more. Just a tiny smidge more. Okay, yeah, we can go up a tiny bit more again. That's now clipping quite heavily, so let's go down a little bit. There we go, that's our clip point. So, that's very equal. That's actually very equal. So both channels there clip very equally, which is nice to see. So we have 19.75 volts per channel. So we need to double that. We need to double that voltage for the bridge. 19.75 times 2, 39.5. So just use a little quick calculator here. So we have 39.5 volts, and that was into 4 ohms. And this is at 12 volts, remember, this is only 12 volts input. So that did 390 watts at 4 ohms in bridge mode at 12 volts. On one of the channels here. So if we work that out, what would that do at 14.4 volts, I wonder? 14.4 divided by our red voltage, which was 12 volts. So we need to times 390, which is our power at 12 volts, times that by 1.44, which gives us 561 watts RMS at 4 ohm bridged. So both channels should do the same. So that's just a little bit over. We'll probably get 1000 watts RMS out of this with all channels driven. Maybe a little bit less with all channels driven, but probably about 1000 watts RMS. I've seen birth sheets of 1000 watts. Yeah, that's correct. You probably will have seen birth sheets of 1000 watts on these amplifiers, because we saw 560 watts on just half of this amplifier. So if both halves are doing over 500 watts, then yes, you will see 1000 watts RMS on the birth sheet. Pretty nice, actually. Good power. Good power. Let's just make sure the rear channels are working the same. So I'll swap my RCAs over to the rear channels, or to amp 2 as they call it. They don't call it front and rear, they call it amp 1 and 2. So let's swap her over and power up again. Nice. That was slightly more power that time. That was ever so slightly more power that time. Only by a little bit. 20.12 volts times by 2. That's 40.24. So about a volt higher. 40.24 at 4 ohms. That was 404 watts RMS, bridge channel at 12 volts. So if we times that, 404.81, times that by 1.44, square law correction factor, 582.92 watts RMS. So if we add that with our 561 watts we saw earlier, that's 1143 watts RMS. That's not a accurate depiction though of this amplifier's power, because we were only loading one pair of channels at a time. If we loaded both of them at the same time, we would probably see it a little bit less, but I reckon that we would still definitely get over 1000 watts RMS out of this amplifier, which is very nice. That's not bad at all. Good job, Kicker, on this amplifier. Good old school Kicker. That's some pretty serious power from a 4-channel Class AB. Best birth sheet I seen was 1200 watts. Man, crazy stuff. Crazy stuff. Very nice. So I'll do an endurance test on this in a little bit. So we'll run this for about 45 minutes. Make sure that it's happy. Make sure that power supply transistor doesn't die again. But yeah, I'm pleased with those results. How many amps did it pull? I don't know, because I'm not bothering to hook up my current sensor to this when I'm bench testing. I'll do that at some point. I'll do that at some point when I've got some spare time. Let's give her a little clean. The top's looking a little bit dusty and dirty here. Let's give her a clean. I think she deserves a clean. So yeah, very nice. That one can go on my completed shelf. Did the fan come on in the end? No, it didn't get hot enough. Didn't get hot enough. It'll probably get hot enough when I do my endurance test, so we'll see if the fan comes on then. Cool. Okay, right. I think that's. I think we're going to wrap it up for today. I've got to shoot off a little bit later this afternoon, so I'm going to go and get ready for that. So yeah, cheers for tuning in, guys. Thank you for watching with me. We had an explosion earlier on. We've had some pretty exciting stuff so far today. Exploding Vibe 10K, and we have a repaired kicker amplifier. So yeah, I'm gonna. Just before I go, I'm going to order the, or just before I leave this afternoon, I'm going to order the parts for the Vibe 10K. So I'm going to order the fresh new output section FETs, and I'm going to order, well, I'm going to wait for the power supply FETs to arrive, load those up, and then the amplifier came on and was working. So that amplifier is pretty much 99% repaired. We just need the new FETs in there. We'll put all those in, and then I'll put it all back in the heatsink, and then we'll run some power on it, make sure that it's happy going forward. So yeah, thanks for tuning in, guys, and I shall see you in the next stream.